Hello Year 5, we're here to mark your arithmetic for today. I hope you got on okay with it. When we do this in school, one of the most important parts is the bit we're about to do now, which is where we get to share different strategies. So if you got a little bit stuck or you didn't know what to do, listening to your friends is a really good way of staying on track. So this is a bit tricky for us being at home, so I'm going to try and help you with that. For the adults at home, hopefully these things that I'm going to be sharing will help you to support your child. If you're a little bit stuck, then please message me on Dojo and I can offer a little bit more support. So for most of you, you will have been having a go at these questions, and then what we sort of say in school is if you are having a go at this and you get a little bit stuck, then yes, you can switch to these questions here. However, it's really important that you start with these because quite often they're a bit more straightforward than they look when you first see them. Some people get a little bit scared and switch to these ones a bit too quickly, so try and have a go at these ones and then by all means then switch to these. Quite often people are doing both sets, which is really good. So let's have a look at the first question. Okay, when we're in school we talk about top tips that we've got, and I know on our working wall before Christmas there were lots of really good tips about how to add numbers together and not to make mistakes. So one of the things that we look at is starting when you do your sum with the biggest number. Now we know with addition the word is commutative, which is a very posh word that means it doesn't matter which order you add the numbers together. However, we know when we're adding sort of two or three numbers together, we don't want to get confused about which number is in which column. So if we start with the biggest one and then work our way down, that generally will help us to get it right. Another thing that we use quite often is the decimal point, and that allows us to line the numbers up correctly because we've got to make sure that sort of, for example, the tens are all in the tens column and the hundreds are all in the hundreds column, because where you put the digits obviously matters, so it will show you how much the number is worth. So we've got to line them up correctly, and often the decimal point can be used to do that. This number here is the only one without a decimal point, so it's a whole number. We know with whole numbers the decimal point comes after the unit, so we're going to line this number up pretending there's a decimal point there. Okay, so this is how I set up my my sum here. Now I'm going to show you this is called the bar model. And it's something that lots of families won't be really familiar with. It's something that I didn't do at school, but we are using it at school. We don't generally use it for addition, but I thought I was going to show it to you just so it's clear. And the idea is that we're looking at these three numbers, adding them together, and this is what we're trying to find is the total. So those three numbers take up the same amount of space as our answer. So we've got 1425.9 and 395, 47.12. And on the next page we're going to look at a subtraction sum where it will be sort of more useful, and you'll see why we use it. So that's bar model. Over here then we've got our sum all set out. Now one of the other things that we do when we make mistakes is that our numbers don't match the question. So when I was writing this up a little while ago, I just looked through again and made sure each number matched with the number up there. What we also decided to do is when we're looking at decimals is making every number have the same amount of decimal places. So 47.12 goes into the hundredths, so I've just put a 00 there and a 90 there. We talk about after a decimal, if you're adding a 0 to the end of a number, you're not making it any bigger, you're just making it a little bit longer. So this number is still 395. Same if we wanted to put a 0 in there and the two zeros in here. The number is longer, but it's not worth any more. Okay, now this is where you're going to laugh at me because I'm going to have to switch to using my mouse, which will make my numbers probably a little bit wiggly, but hopefully it will help. So if Tia was here, she'd be telling me before I start I'm going to put my decimal point in, because that's another mistake that we can make, is that we do all the calculations, all the difficult part, but we forget the decimal point. So if we put that in before we start, then we won't forget it. So we're just going to go along. So 0 add 0 is 0, add 2 is 2. Okay, and then 9 add 0 add 1 is 10. So we're going to put the 0 in there, and we're going to carry over, okay, the 1 here. So when we read that number, it says 10. If you put the 1 there and the 0 there, it would say 0, 1. So just make sure when you read it going across, it says the number that you're looking for. Okay, now we're looking at numbers that are going to take us over 10. So we're looking for pairs of numbers that can add together properly. Sorry, not properly, easily. So if I'm looking at 5, 5 and 7, I know 5 and 5 straight away is 10, add 7 is 17, and then add the 1 is 18. So I'm going to cross out that 1 to show that I've counted it. If I get the wrong answer and I look at all the ones I've carried underneath and they're not crossed, that's probably where I've made my mistakes. We cross it off to show that we've counted it. So I'm looking here at 2, 9, 4 and 1. Now I know 9 and 1 make 10, and 4 and 2 make 6. So 10 add 6 is 16. Okay, so all the time I'm trying to be efficient. That means trying to do it the fastest way but without making mistakes. Okay, so that was 16, so I need to carry another 1 here. So I've got 4, 3 and 1. Well, 3 and 1 make 4, and add that to the other 4 is 8. Okay, and then I've got a 1 there. Now you may have set up slightly differently. You may have added these two numbers together first, then added it to that one. You may have put zeros in here, just so all of the numbers are exactly the same length. Again, you can see that number is still 395 even though it's got the 0 at the front. Okay, so that is our answer, and hopefully your answer matches mine. Now I'm going to fill in the top of my bar model to show, and this is painful. If I was at school it'd be much faster, but never mind. Okay, so we know that those three numbers added together give us that answer, which is 1868.02. You don't need the comma there, but we often put it in to help us read the number. Okay, hopefully you got that right, and I've shared some of the mistakes that that we often try to sort of talk about before we do the sum to remind us. So hopefully if you've made a mistake, you know where you've gone wrong now, so tomorrow you should get it right. Okay, let's move quickly on. Right, here we've got the bar model again. We've got subtraction this time. So 17.9, subtract or take away something, leaves us with 9.5. So we've got the biggest number this time. We've got 17.9. Now, two numbers add together to make 17.9. We know one of them is 9.5 for this sum. Okay, and then this is what we are trying to find. All right, so say for example it was an addition sum, we might have 9.5 add this number equals question mark, which would be 17.9, but we use the bar model to represent the numbers, so we've got two numbers that add together to make that number. For example, if we had that number and that number, this would be the part that we're looking for, so we would do that number subtract that number. We'll keep looking at the bar model. It's something that, as I said, lots of adults won't be very familiar with, but it's a way of representing sums and problems so the children can see what they're looking for. So let's have a look. I filled it in there for you again. So let's switch now to using my lovely mouse, and hopefully, so I've got 17.9. Okay, if I subtract 9.5 from it, I will be able to know what that missing number is, because if I've got that and I take that part away, I'm left with this bit here, so that's why I'm subtracting it. That wasn't very good, but we'll have to keep it. Okay, again, Tia would remind me to put my decimal point in, so I'm going to put it in. Right, I've got 9 subtract 5, which is 4. When we're subtracting, you can count up, so you can take away or you can count up. So for some of you, 9 take away 5, you can imagine that. I can see that on my fingers now. I've got 5 up on one hand, 4 up on another. If I take those 5 away, I've got the side that's got 4 left. However, for some of you, you might want to count up, so count from 5 and go 6, 7, 8, 9. That's a difference of 4. Okay, now I've got 7 subtract 9. A mistake that people often make will just switch it around and they'll say, okay, I'm going to do 9 subtract 7 instead. But we can't, because the number at the top has to stay as it is. So this time I'm going to exchange. So I'm going to exchange from the tens column. I've got one lot of 10, so I'm going to borrow that or exchange it. Okay, and I'm going to move it over here. So I borrowed one lot of 10, my number was 7, now it's 17. So that's my one lot of 10 and that's my 7. So I'm now going to count up. For me, that's easier. You might want to count backwards, it's up to you. But I'm going to count up from 9. If I add 1 to 9, I get 10, and then from 10 to 17 is 7, so 1 and 7 is 8. Okay, so if I'm looking there, this is my missing part here, which is 8.4. Hopefully you have matched me and I haven't made a silly mistake. So 8.4 is the answer for that one. Right, we're looking now at multiplication, and we're looking at using our understanding of the number system. So we're looking here, hopefully you'll know or you'll remember what all of these stand for. So this is all about place value. So this is about the understanding that where you put a digit, okay, so in which column will tell you how much it's worth. So if I put a 5 here, okay, yes, it's still a 5, all right, but where it is means it's worth 500, okay. So if my number is 571, I've got 5 lots of 100, which is 500. I've got 7 lots of 10, so it's 70, and I've got 1 unit. Sometimes we call that ones. So this is really handy when you're looking at multiplying multiples of 10. So if we're looking at 700, we know it's in the 10 times table because it's got zeros at the end of it. Okay, same for 2000. Okay, so what I would be doing for this one, the most efficient way I think, is thinking about, I know 700, okay, multiplied by 2 is, and I'm actually going to switch, I'm going to type it because you'll be able to read it better. So 700 multiplied by 2, and I'd ask you to put your hand up and tell me, and hopefully you would tell me that's 1,400. All right, so now I look up here and I'm going to say, okay, if that was 700 times by 2, it's 1,400 or 1,400, but I'm timesing it by 2,000. So I need to think about 1,400 multiplied by 2,000. Sorry, multiplied by 1,000, I apologise. So just to recap that, so instead of timesing by 2, I'm going to times by 2,000, which is 1,000 times bigger. Okay, I'm going to make sure I'm saying the right thing. So I'm going to switch back to my pen, and I've got 1,400. Now if I'm timesing by 1,000, because I want to times by 2,000 instead of 2, we have to think about how many columns we're moving up. So when you move a column, it's getting 10 times bigger. Okay, so when you move down a column, your number's getting 10 times smaller. It's worth 10 times less than it was. Or if you're moving up, it's worth 10 times more than it was. So if we're timesing by 1,000, okay, there are 3 zeros in 1,000, so we have to move it up 3 columns. So I'm in the thousands, 1 column, 2 columns, 3 columns. So I'm now in the millions. And you have to keep everything in the same order. So my answer was 1,400, okay? I don't mess up the order because otherwise I'm timesing it by something else. If we keep it in exactly the same order, okay, we'll get the right answer. So I've got my 1,400. However, if I wrote that as an answer, it still is 1,400. So now what I need to do is to fill in and use zeros as my placeholders, filling any of the empty columns until I get to my decimal point, okay? So I'm looking there, and every 3 digits we're going to put in our our commas so that we can read it. So the answer is 1,400,000. Okay, another way of looking at this, if you didn't want to jump straight to using that answer and then timesing it by 1,000, okay, you can have a look at doing 700 multiplied by 2 is 1,400. Okay, so then 700, I'm looking back at my sum, I'm going to do it now by 20, would be 10 times bigger. Okay, so that would be 14,000. Okay, so I'm looking back, I'm still not there. 700 is right. I'm now going to make it 10 times bigger. So I'm timesing it by 200 this time instead of 20. Okay, so instead of 14,000, it's going to be 140,000. I'm going to go back and just put the commas in so that you can read the numbers. That isn't in the right place. 14,000 and then 140,000. Okay, now we've talked in school, you can't just add a 0. That always makes my head almost explode, because if you times it by 10, yes, you move everything up, and yes, you use a 0 as a placeholder. However, if we're looking at the number, let me do another one. If I was looking at the number 9.5 and I was timesing it by 10, and if I just added a 0, it still is 9.5. So it's really important that you don't think about the decimal point moving, that always stays the same, but also just adding a 0. You've got to have that understanding of numbers moving up or moving down. Okay, so if I go back, my sum isn't quite complete. 700 multiplied by 2,000 this time. So it's going to get 10 times bigger, so it's going to be 1,400,000. Okay, so hopefully you got the right answer. It was a tricky one, but again, there's two different ways we've shared of doing that, and it depends how confident you are with multiplication. I would say this is the more efficient way. So looking at 700 multiplied by 2, getting this answer and then timesing it by 1,000. However, this is the way that shows your understanding. And if you're really confident with that, you'll quickly move on to this method. Okay, right, let's keep going. So 900 divided by 30. So this is one I was going to show you. When we're dividing, we're thinking about how many lots of 30, how many times can you get 30 into 900. Now hopefully you looked at that and thought, hang on, 3 and 9, I know that 9 is in the 3 times table, so there is a connection between those numbers. So you might have thought, okay, I'm not going to think about 900, I'm going to divide it by 10 and make it 90, because it's a much more familiar number, and I'm going to think about how many times 30 goes into 90. So I'm trying to think or find a fact that I know quite easily to help me find out one that I don't know. So 90 divided by 30 is 3. Okay, would you agree with that? There's 3 lots of 30 and 90. So if you count, it would be 30, 60, 90. Now, I was able to do that quickly because I used my 3 times table, 3, 6, 9. So the 30 times table is 10 times bigger. So we're thinking about there's 3 lots of 30 and 90. So I can use that then and say that there would be 10 times, okay, if we're thinking about 90 to 900, there's 10 times more amounts of 30 and 900, because the number I'm dividing by from 90 is now 900 is 10 times bigger. My answer is going to be 10 times bigger. So there are 30 lots of 30 in 900. Okay, so I could say 30 times 30 is 900, or 900 divided by 30 is 30. Okay, now this is another way of looking at it, which is slightly easier but ends up being a bit more complicated. So you might have done, actually I'm not going to think about 90, that's a bit tricky for me. I'm going to make it 9 divided by 3. Okay, so I'm thinking how many 3s are in 9, so 9 divided by 3 is 3. And so I'm going to think, okay, if I had 90 divided by 3, it would be 30. And then 900 divided by 3 would be 300. Okay, so at the moment, my first number is the same as in the question, but I'm dividing by 3. I need to divide by 30. Okay, hopefully that makes sense. Now, I need to think, hang on a minute, the number I'm dividing by is 10 times bigger. So I'm going to get 10 times less as my answer, because the number I'm dividing by is much bigger, it's 10 times bigger. So all I have to do is divide my answer by 10, so it's 30. Okay, again, that is quite tricky, but hopefully you will have found your way through it and, as I said, used your knowledge of timesing and dividing by 10. Okay, let's move on. Right, now we've got here, these were the ones on the other side of the board. So again, when I added them together, I put my decimal point in, I made sure I added carefully. And the last thing I left to do to show you is show that I've marked off that one that I have carried over. So 44.2 is your answer. Okay, and then this one here, we've got 171 subtract 80. I had 2 sort of different ways of doing this. For me, I would do this mentally, and I wouldn't really draw a number line, but I'm showing you what I do in my head. So when we're subtracting, we can count up. So I'm counting up from 80 to 171. So in my head, I know if I add 20, I get to 100. Okay, and then I've got another 71 to get to 171. So if I add those 2 numbers together, that is my answer. For lots of you, you will be able to do that in your head, and that's no issue. Some of you, it might be handy to write down a number line like this, and then to add the numbers together. And then we have here my scruffy sum, where I have just written it as a sum, and then I had to do an exchange there, so the answer is still 91. Okay, 2 different ways of doing it. Okay, now 915 divided by 10, I've got my place value information there. So when I divide by 10, I'm moving everything down 1 column. So my 9 is now going to be worth 10 times less. So instead of 900, it's worth 90. My 1 is going to be worth 1 unit, or 1 instead of 10. Got to put my decimal point in again. And then my 5 was worth 5 units, or 5 ones. It's now worth 5 tenths. So our answer is 91.5. Okay, last question. Right, when we're in school, lots of people are terrified of word problems, and lots of people don't even give it a go. So we have something called UDC, and our first job is to underline. So this is a way of working that even if you're not sure how you're going to find the answer, you've got something to do. So our first job is to underline any key information. Every child is able to do this. So we've got 24 children working at home, and each complete 1.5 hours of learning in the morning. How many minutes of learning have been completed by the whole class? So we have to think what is important. It's quite a long couple of sentences. Let's focus on what is important. So 24 children. Does it matter they're working at home? No, it doesn't. They each complete 1.5 hours. Okay, it doesn't matter if they're learning or whether they're sleeping or playing, doesn't matter. It doesn't matter that it's in the morning. It says how many minutes of learning have been completed by the whole class. Now, they want an answer in minutes, not in hours. Okay, and we're thinking about the whole class. All right, so those are the important bits of information that we've got. So we now need to do something with it. So we're going to draw something. So I'm going to draw a little diagram, and I'm going to draw a boy and a girl. Okay, and then above it I'm going to write the number 24. Okay, I'm not going to draw 24 different people, but I've got 24 people, and each of them is doing 1.5 hours of learning. Now straight away that's a bit more sort of straightforward, I think, because we've got 24 times by 1.5. That is what we've got to do. Now that answer will give us the answer in hours, which will then help us to work out minutes. So I'm thinking about 24 multiplied by 1.5. Now multiplying fractions is tricky, so let's have a look at this. Instead of doing that, I'm going to think about, my first job is to think that if it was 2 children, they would be working for 3 hours. Okay, hopefully you agree with me about that. So 1.5, if we've got 2 lots of 1.5, that would be 3 hours, because 2 lots of 1 is 2, and then 2 lots of half, or half an hour, is another hour. So I can use that to think, actually, if I've got 4 children, I'm trying to move that out of the way, it's annoying. 4 children would be working for 6 hours. Okay, hopefully you're following me. Now, they are going to be the 2 bits of information that are going to be really useful. I can use that and think, I'm going to go to this one and think, if 2 children work for 3 hours, then 20 children will be working for 30 hours. Because I've got 10 times the amount of children, so I've got 10 times the amount of hours. Okay, now if I'm trying to find 24 children, okay, I've got 4 children there and I've got 20 children there. If I added those 2 together, I get 36 hours. So as a class, they've worked for 36 hours. Now if we go back to our question, have we answered it? No, we need minutes. So our sum that we're actually trying to answer is 36 times by 60. Okay, because 60 is 60 minutes. We know that there are 60 minutes in an hour. So the way that we would do that, the most efficient way, I'm going to switch pens just so it stands out a bit more to you. Okay, I've got 36. Okay, I'm going to times it by 6 instead of 60. Okay, and I'm going to use that to help me then. So 36 times 6. I've got 6 times 6 is 36. Okay, and if you don't know your 6 times table, you can write it down. You can think, I know that 6 times 5 is 30. You all know your 5 times table. You can count in 5s. So use something to help you if you're not quite sure. Then 6 times 3 is 18. Add the 3, so 18 add 2 is 20, and 1 more is 21. Okay, so I know the answer for 36 times 6 is 216. So it'd be 216 minutes. However, I'm timesing it by 60, so it's 10 times bigger, so it would be 2,160. That is your answer in minutes. Okay, so hopefully you will all be working for at least 2,160 minutes as a whole group. Right, I know that's quite long and the others won't be as long, but I've just tried to share some strategies to remind you, but also to help your grown-ups. So yeah, let me know how you got on, and then hopefully you can use some of these strategies tomorrow to help you be a bit more confident. Okay, thank you.